Hello and welcome. If you look up at the night sky lately, you might notice it's getting, well, a little busier these days. But the real story isn't just about what we can see, it's about the hidden consequences of our rapidly crowding orbits.
Welcome to another episode of Environmental Digest. Today, we're going to talk about the hidden pollution from our satellite revolution. We're diving into a real paradox, how our mission to connect the planet from space might be creating a brand new environmental headache right here in our own atmosphere.
So to kick things off, get a load of this number. Right now, there are over 14,300 active satellites orbiting Earth. And to put that in perspective, just 2 decades ago, that number was only 871. That is an absolutely explosive growth. And believe me, it's changing everything.
So, what is driving all of this? Well, you could call it a new kind of gold rush, but this time, the gold is hundreds of miles above our heads in what we call low Earth orbit.
And this isn't just about governments or militaries anymore. Oh no. The main engines behind this boom are commercial companies building something called mega constellations. Just imagine thousands of satellites all working together, launched by giants like SpaceX and Amazon, all with the incredible goal of blanketing the entire globe in high-speed internet.
And hey, if you think 14,000 is a lot, you might want to sit down. Projections show that another 58,000 satellites are planned for launch in just the next decade. Yeah, we are only at the very, very beginning of this whole thing.
Okay, but with thousands of objects zipping around the planet at mind-boggling speeds, a pretty obvious problem starts to emerge, right? Orbital traffic. And this isn't your average traffic jam. It's more like a high-stakes collision course.
This brings us to a potential nightmare scenario for spaceflight, something called the Kessler syndrome. The basic idea is that once space junk gets too dense, just one collision could trigger a chain reaction. See, each crash creates more debris, which then causes more crashes and on until entire orbits become totally unusable. It's a terrifying thought.
So, to dodge that catastrophe, we've got to get old satellites out of the way. The internationally accepted solution is actually pretty simple. Just bring them down. Decommissioned satellites are guided back into Earth's atmosphere for disposal. It really does seem like the perfect, clean way to keep space tidy. The whole process looks really straightforward. When a satellite's mission is over, its orbit gets lowered. It gets snagged by Earth's atmosphere, and thanks to some incredible friction and heat, it just burns up. Problem solved, right? Out of sight, out of mind.
Well, this is where our story takes a really sharp turn, because that simple phrase, burns up, is hiding a much more complex and, frankly, pretty troubling reality.
Let's really stop and think about that for a second. What does burning up actually mean? When a multi-ton object made of all kinds of metals and electronics hits the atmosphere going thousands of miles an hour, where does all that stuff go?
As one source puts it, what we're really doing with all this satellite reentry is conducting, and I quote, an unregulated global chemical experiment. Wow, that does not sound like a clean disposal at all. And here's where we get to the heart of it. The myth is that these satellites just disintegrate into nothing. Poof, they're gone. But the reality? They vaporize. They transform into a superfine dust of metallic particles, mostly aluminum oxide, also known as alumina, which then gets deposited way, way up in the most chemically sensitive layers of our atmosphere. And because these particles are being injected so high up, the effects aren't just local. This becomes a global issue. It's an experiment that we're all a part of, whether we know it or not. So, what could happen? Well, scientists are just starting to figure it out. This metallic dust might trigger chemical reactions that chew away at a protective ozone layer. It could change how high-altitude clouds form, which in turn could mess with Earth's climate balance. It could even interfere with our ability to study the atmosphere in the first place. This chart just illustrates the scale of the problem so perfectly. For basically all of history, the only metals in the upper atmosphere came from meteors burning up. But now, the amount coming from our own space waste is becoming a huge piece of the pie. For some metals, our junk could soon dump more into the atmosphere than nature does. And this fallout isn't just some invisible atmospheric dust either. The sheer number of satellites is creating a much more visible problem, a whole new kind of light pollution that's threatening our view of the universe even from our best telescopes. I mean, just think about this. Projections show that once all these mega constellations are up and running, a full 1/3 of all images from the Hubble Space Telescope will be streaked with satellite trails. That's priceless scientific data just contaminated. And remember, Hubble is in space. It was supposed to be safe from this stuff. All of this, it brings us to a really critical moment. The pace of this new space race is just accelerating so fast that we're deploying the technology way, way faster than we can understand its consequences. Just look at this timeline. Between 2015 and 2020, things were pretty stable. But since then, as the first mega constellation started coming online, the massive junk re-entering our atmosphere has more than doubled. And the projections for the coming years? It's just an explosion as thousands of these first-generation satellites start to deorbit.
This quote from one of the reports really just sums it all up, doesn't it? We're running this massive experiment on our own atmosphere with very little idea of what the outcome might be. We're essentially flying blind. So here's the bottom line. The technology is here. Satellites are launching by the thousand, and they're already starting to come back down. But our scientific grasp of what that all means, for the ozone, for our climate, for the planet's delicate atmospheric balance, it's lagging dangerously behind. And it all leaves us with this one fundamental question. This satellite revolution promises unprecedented global connectivity, and that's a truly remarkable achievement. But as we reach for the stars, are we overlooking the price we might have to pay right here, in the very air we breathe?